ಹಲೋ ಹಲೋ
ಹಲೋ ಇಲ್ಲ ಮ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ
ಅಲ್ಲ ಕೇಳುತ್ತೆ
ಹಲೋ
ಅಲ್ಲ ಅಲ್ಲಿ ಕೇಳುತ್ತೆ
ಹಲೋ
ಹಲೋ ಹಲೋ
ಲೇಟ್ ಆಗ್ತಾ ಇದೆ.
ಇವಾಗ ಆಡಿಯೋ ಬರ್ತಿದೆ ಅಲ್ಲ? ಓಕೆ, ಆಬ್ವಿಯಸ್ಲಿ ವಿಡಿಯೋನು ಬರಬೇಕು. ಪರ್ಫೆಕ್ಟ್ಲಿ ಆಲ್ ರೈಟ್ ಅಲ್ಲ? ಏನೇ ಒಂದ್ಸತಿ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಆದ್ರೆ ನಾನೇನ್ ಕಾಣಲ್ಲ ಅಲ್ವಾ ಯೂಶಲಿ? ಹೌದಾ? ಓಕೆ 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 ಓಕೆ. ಈಗ ನಾನು ಈಗ ಶೇರ್ ಹಾ ಹಾ ಯಾ ನೋ ಪ್ರಾಬ್ಲಮ್.
Sir, am I audible, sir?
Yeah, you are audible.
Fantastic, sir. Sir, I think probably you can share it, sir, now.
1 second.
Your screen is visible, sir. Laptop screen.
ಹಾ ವಿಸಿಬಲ್ ಅಲ್ವಾ?
ಈಗ ಬರ್ತಾ ಇದೆ ಸರ್. ಈಗ now it is perfect.
ಪರ್ಫೆಕ್ಟ್ ಅಲ್ವಾ? ಓಕೆ
ಸರ್,
ಓಕೆ.
ಆಮೇಲೆ ಒಂದು ಮೇಜರ್ ಥಿಂಗ್ ಸರ್, ಇಲ್ಲಿ ನೀವು ಅನ್ನೋಟೇಷನ್ ಡಿಸೇಬಲ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸರ್. ಅಲ್ಲಿ ಸೆಕ್ಯೂರಿಟಿ ಅಂತ ಇರ್ಬೋದಲ್ಲ, ಅಲ್ಲೆಲ್ಲರೂ ಒಂದು
ಸೆಕ್ಯೂರಿಟಿ ಅಂತನಾ? ಇಲ್ಲಿ ಯಾವ್ದು ಕಾಣಿಸ್ತಿಲ್ವಲ್ಲ. ಈ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಇಂದ ಹೊರಗಡೆ ಬರಲ್ಲ?
ಇಲ್ಲ ಸರ್, ಇಲ್ಲೇನೆ ನೀವು ಸ್ಕ್ರೀನ್ ಶೇರ್ ಇದ್ದಾಗ್ಲೇನೆ
ಹಾ
ಅನ್ನೋಟೇಟ್ ಅಂತ ಎಲ್ಲರೂ ಇದೆಯಾ ಸರ್ ನೋಡಿ ಅಂತ.
ಮೋರ್ ಇದೆ, ಮೋರ್ ಆಪ್ಷನ್ಸ್,
ಮೋರ್ ಇದೆಯಾ ಸರ್ ಆಪ್ಷನ್ ನಿಮ್ಗೆ?
ಇಲ್ಲಿ ಯಾವ್ದು ಇಲ್ವಲ್ಲ.
ಸೆಕ್ಯೂರಿಟಿ ನಾವು ತೆಗೆದಿದೀವಲ್ಲ
ನಾವು ತೆಗ್ದಿದ್ದೀವಿ ಸರ್.
ಹಾ ಇಲ್ಲಿ ಯಾವ್ದು ಇಲ್ಲ ನನಗೆ.
ಇಲ್ಲ sir?
ಬೇರೆ ಆಪ್ಷನ್ ಏನ್ ತೋರಿಸ್ತಿಲ್ಲ. ಅಂದ್ರೆ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡಿದ್ಮೇಲೆ ಬೇರೆ ಆಪ್ಷನ್ ಇಲ್ಲ. ಎನಿವೆ ಇವಾಗ ಕರೆಕ್ಟ್ ಆಗಿದೆ ಅಲ್ವಾ?
ಕರೆಕ್ಟ್ ಆಗಿದೆ ಸರ್. ಅಲ್ಲ, ನನಗೆ ಹುಡುಗರಿಗೆ ಏನಾದ್ರು ಆಪ್ಷನ್ ಸಿಗುತ್ತಾ ಅಂತ ಸುಮ್ಮನೆ ಏನೇನೋ ಕೂತಿರ್ತಾರೆ ಅಲ್ಲ. ಜಸ್ಟ್ ಜನರಲಿ ಐ ಸ್ಪೀಕಿಂಗ್ ಸರ್.
ಓಕೆ ಓಕೆ ಓಕೆ.
ಐ ವಾಂಟೆಡ್ ಟು ಮೇಕ್ ಶ್ಯೂರ್ ದಟ್
ಇವಾಗ ನಂದು ಸ್ಕ್ರೀನ್ ಮಾತ್ರ ಕಾಣಿಸ್ತಿದ್ಯೋ ಅಥವಾ ಈವನ್ ಐ ಆಮ್ ಆಡಿಯೋದಲ್ಲಿ ಇದರಲ್ಲಿ ವಿಡಿಯೋದಲ್ಲಿ ಇದೀನಾ?
ಸರ್, ನೀವು ವಿಡಿಯೋದಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಸರ್. ನೀವು ವಿಡಿಯೋದಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಈಗ.
ಇಲ್ಲ ಅಲ್ವಾ? ಫೈನ್ ಫೈನ್ ಫೈನ್. ಹೀಗೆ ಇರ್ಲಿ ಬಿಡಿ, ಇಟ್ ವಿಲ್ ಬಿ ಕಂಫರ್ಟಬಲ್.
ಹಿಂಗೆ ವಿಡಿಯೋ ಏನಿಲ್ಲ ಸರ್. ವಿಡಿಯೋ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ನೀವು.
ಸರಿ ಸರಿ ಸರಿ.
ಆನ್ ಮಾಡ್ಕೊಂಡಿಲ್ಲ ಸರ್.
ನೀವು ವಿಡಿಯೋ ಓಕೆ. ನೀವು ವಿಡಿಯೋ ಅಲ್ಲ ಸರ್, ವಿಡಿಯೋ ಆನ್ ಮಾಡ್ಕೊಂಡಿಲ್ಲ, ನೀವು ಆಫ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ ಸರ್.
ವಿಡಿಯೋ ಆಫ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಾ?
ತೊಂದ್ರೆ ಇಲ್ಲ ಸರ್, ತೊಂದ್ರೆ ಇಲ್ಲ. ನೋ ಪ್ರಾಬ್ಲಮ್.
ತೊಂದ್ರೆ ಇಲ್ಲ ಅಲ್ವಾ? ಸರಿ ಸರಿ ಸರಿ.
Yes, sir.
ಯಾಕಂದ್ರೆ ಫಿಕ್ಸ್ ಆಗಿದೆಯಲ್ಲ, ಮತ್ತೆ ಇನ್ನು ಮಿಸ್ಟೇಕ್ ಆಗೋದು ಬೇಡ. ವಿ ಕ್ಯಾನ್ ಕಂಟಿನ್ಯೂ ವಿತ್ ದ ಸೇಮ್ ಸ್ಕ್ರೀನ್ ಅಲ್ವಾ?
ಎಸ್ ಸರ್, ಎಸ್ ಸರ್. ಅಡ್ಮಿಟ್ ಅಲ್ಲಿ ಮಾಡ್ಬೇಕಲ್ಲ.
ಇಲ್ಲೇ ಮಾಡ್ಬೋದು ಸರ್.
ಅಲ್ಲ, ಒಂದು ನಿಮಿಷ ಸರ್. ಇನ್ನು 2 minutes ಜಸ್ಟ್ ಗಿವ್ ಅಸ್ ಟೈಮ್ ಸರ್. ನೋ ಪ್ರಾಬ್ಲಮ್.
No problem. Absolutely no issues.
Please,
Take
sir,
your
please.
time. Take your time.
Please sir, please sir.
Okay, okay, okay.
Sir, with your permission, can I allow the student, sir?
Yeah, please, Raju, please.
Yes, sir. Yes, sir. Sure. What's this, sir? I request all the students to close their videos. Ankit, Aniket. Sir, with your permission, I would like to start the event activity, sir.
Yeah, please, Dr. Raju, please.
Yes, sir. Good afternoon to all. It's a great honor that today, as part of the academics, we have from last year we are conducting alternate assessment tool as a reflection note. On the note of it, we have requested our one of the eminent personality. He is the CEO of Pyro Technologies. He has been with us from past 4 or 5 years because he is the member of ECSI, Electrochemical Society of India also. Mr. Rajiv Dikshit has here for many of the activities like the faculty development program and for invited talks also. Dear students, as you all know that the chapter we have, that is corrosion science and metal finishing, which is very relevant with respect to this topic, what exactly our guest Rajiva Dikshit is going to deliver today. It is a great honor for us. So on behalf of Department of Chemistry and on behalf of Dayanand Sir College of Engineering, I would like to welcome him, and also I would like to thank him for accepting our invitation. So whatever the necessary instruction is given by the teachers, I think probably you are going to follow it up. Sir, I take this opportunity to welcome you, sir, for this event and occasion, sir.
Thank you, Dr. Raju.
Now I request Dr. Dinamani M, Associate Professor, Department of Chemistry, to introduce the speaker. Madam, over to you.
Yes, sir. Thank you, sir. Good afternoon, one and all. Myself, Dr. Dinamani from the Department of Chemistry. I feel privileged to introduce today's speaker, Rajiva Dikshit. His presently is a CEO and founder of Pyro Eco Green Technologies Private Limited in Bangalore. Mr. Rajiva Bankapura Sundara is Governing Council member and Vice President of Electrochemical Society of India, Indian Institute of Science, Bangalore. He is the founder and CEO of Pyro Eco Green Technologies Private Limited, Bangalore, which focuses on providing green solutions for surface treatment with metal finishing and caters to the needs of industries, government, and defense organizations. He has 30 years of professional experience, which spans from consultations, operations, leadership, and manufacturing globally. Appreciated best clean technologies for companies of international reputation, such as Cummins Group, Wipro Group of companies, Bosch India, and Germany, Helvet Packard, and Ford India Limited, HAL, BEL, and Reserve Bank of India. And his thrust areas include eco-friendly process and products, surface treatment, metal finishing applications. Sir, we are fortunate to have you here as today's speaker, and I hope our students are richly benefited by your talk, sir. And let us have the pleasure of listening to you now, sir, on the topic eco-friendly surface treatment and metal finishing. Over to you, sir.
Yeah, thank you, madam. Thank you very much. Good evening, all of you. Today I'll be sharing some of the work that which we have done in your company, and probably some of the experiences which I have, which I am associated with many industries and institutions. Basically, I'll be talking on eco-friendly technologies for surface treatment metal finishing. Of course, a bit on corrosion and a few slides on waste to wealth also. It is very much related to this. But having said this, the most important point what one should know before beginning of all these things is QC is the one word always we should remember: quality, safety, health, and environment. Based on this, if any manufacturing industry is doing, I feel they'll be doing a great job. When we neglect this particular thing, always we get into issues. So let me start with my first slide. Generally, metals and alloys undergo many operations, right from not only the raw material, manufacturing of raw material itself, to the finished products. So surface contamination is obviously, it will be there for one or the other reasons, right from the processing, right from the raw material, right from various activities that industries will do. And the impurities are mainly oxides, hydroxide. You have grease, oil, organic compounds, salts, well spatters, and many other process contamination depending on the industry. And impurities are usually removed by chemical and electrochemical or mechanical methods. Pickling is one of the most common method to clean metals and alloys. This is just a basic background which I'm trying to give it to you. When we say chemical pre-treatment, the pre-treatment is mainly for cleaning. Cleaning to what? To prepare the surface for the subsequent coating. It may be a powder coating, painting, or metallic coatings like copper, nickel, gold, or any other thing. If we don't clean the surface properly, cleaning is what? To remove all organic and inorganic soils, basically. What are organic soil? Generally, it will be grease, oil, and other things. And the inorganic will be always metallic oxides. The oxides with respect to the metal. If it is copper, copper oxide. If it is iron, Fe, ferric oxide, ferrous oxide. And like this aluminum, aluminum oxide. We need to remove all the contaminants. When I say we need to clean, it should be 100%. So in the industry, the basic norm is either it is cleaned or it is not cleaned. 99.9% of cleaning is also not acceptable in many of the cases. Exceptions are always there. If you talk about aerospace or if you talk about the space technology, they will not tolerate even ppm level of contaminants. So it is very important to clean the surface to get the desired results. So when we say cleaning, there are many methods. As I said, the chemical is one of the methods which I'm going to talk on. And there are many methods involved in this. You can take any cleaner, just wipe on, wipe off, maybe one of the technique, or you can immerse the component which is soiled for a certain time, followed by a water wash, you can get a clean surface. The immersion can be aided by ultrasonic effect, ultrasonic waves. I think you must have known, all of you know about that. Or electrochemical cleaning, either it is an anodic cleaning or cathodic cleaning, or high pressure spray. These are all the methods, which one can use to enhance the cleaning property or to aid to your chemicals. And sometimes phosphate coating and metal coatings can also be a pre-treatment, because especially for iron based alloys, if you don't have the phosphate coating, you will not get the right adhesion for the subsequent painting or powder coating. So phosphate coating is very, very important. Of course, phosphate coating also, we have the iron phosphating or zinc phosphating or magnesium phosphating. These are the three main phosphating which industries use. There are many other phosphating also, which is coupled with sometimes PTFE, nickel, cobalt, or many other ions which we would like to have to get the right coating. So specifically, this is only a few of the fundamental things I am telling. In depth, when we go, we need to study what is the type of the metal. That means what is the chemistry behind that, metallurgical properties like hardness, surface structure, and based on the subsequent coating what we are going to select, one has to prepare the basic material. And preparation of metals and alloy is one of the most important and fundamental step in surface treatment or metal finishing, the matter of fact, for any industry, basically engineering industries. So when we talk about corrosion, corrosion can be of many things. Corrosion is not only for steel. Corrosion is for most of the metals and alloys. Anyway, we'll discuss one by one. The main difference what the general chemical which being used in the industry and what we are doing in our company, the only difference is the technology is green. Conventionally, what we use for cleaning, let us say ferrous or iron, if you want to remove the rust, conventional way is to use some kind of an acid like hydrochloric acid or phosphoric acid or sulfuric acid or combination of all these things. These acids are quite hazardous in nature. That is, it is highly corrosive and it emits toxic fumes also. This is one of the slide which clearly gives you an idea. This is a label basically, GHS systems, what we call it as, which clearly says what type of hazard is there. When we talk about acid, definitely we have corrosive. And when the irritant, the corrosive, and the toxicity also. And when we talk about some of the solvents like benzene, toluene, and other thing, naturally it will be highly flammable. And all these things are environmentally, it is not safe again. And there are a few toxic things also apart from the solvents, if you use, let us say for degreasing, industries use a lot of trichloroethylene, perchloroethylene. These are all chlorinated compounds which are highly toxic and create cancer also. Not only that, these are all ozone depleting. So like this, most of the chemical, or I should say more than the most, I should say, it's not a right word, but still almost 100% of the chemical, most of the industries what presently being used, not only in India, in abroad also, are totally hazardous, which is creating a lot of problem for the environment. So some of the industries with knowledge they are doing, and most of the industries without their knowledge they are doing. So particularly in this presentation, whatever I'm going to share, I'll be always using the words like eco-friendly, non-hazardous, non-toxic. These are all the primary things what I want you to note down. So when we say eco-friendly chemistry or eco-friendly solutions or eco-friendly cleaners or eco-friendly pre-treatment or treatment solutions, it has to pass few of these non-hazardous, non-flammable, non-ozone depleting, non-carcinogenic, and definitely should be biodegradable. There should not be any VOC. VOC is volatile organic compounds, and it should be obviously non-corrosive and preferably from a renewable source. If your product or your chemical is based on all these things, then it can be considered as a green product or an eco-friendly solution. I'll be sharing few slides with respect to the industrial practical problems which they are facing and some of the solutions that which we have offered them. And this is slightly away from your curricular, your subject and other thing. If anybody has any questions, you can stop me. You may please ask me for that. So let me start with some of the ferrous metals and alloys. This is one of the ferrous dye which is used for stamped car bodies. So whenever you manufacture a car, you need to have those doors and other outside body which is made up of CRCA that has to be pressed and taken into a required shape. This is one of the dyes. After a few years, obviously you can see a lot of corrosion on the total surface. It is rusted basically. Or even some of the train tracks, you can see it is corroded. Even in the food industry, this is a chocolate crushing rollers basically. When it is not used for some time, it will get rust. So when we talk about steel, rusting is always an issue, and the main thing what we need is a removal of the rust or removal of the corrosive ions, and also preventing it from further rusting. These two are the major challenges in any industry when it comes to steel. Obviously, all of us know without steel, it is hardly any industry is there who are working. So it is very, very important to know the method, the techniques which are available and how we can improve that and what are the safer alternative which is available to do this. Because this is one of the slide which you can see, there are number of tanks, but these are quite small. In some of the industries, the whole area is going to be at least, I should say, you will have very happen. And these tanks will be filled up with hazardous acids, like earlier I said, the hydrochloric acid, which is one of the pickling agent to clean the steel. It removes the rust. Anyway, with a low pH, any of the low pH solution will definitely remove the rust. And since hydrochloric acid is one of the very cheaper acids compared to any other acid, industries are using that. And you can see these pipelines which are there. It is there only to take away the fumes which comes out of the system. That is because of the hydrochloric acid. So it is not only the toxic fumes are going to affect the environment, but also it corrodes the steel also if you don't use it at a proper percentage or at a proper time. And what we have done, see, this is one of the component, which is a cast iron cylindrical housing, and it is heavily rusted. To remove the rust, what we did is we just use a citric acid base, some of the wetting agents, and instead of a conventional solvent, we have used the extract of the lemon, orange, and other things. These are all essential oils, you can say. When you combine these things, you can definitely come up with a very good product which is totally eco-friendly, which can remove both inorganic and organic contaminants. So from here to here, we can comfortably remove the rust without affecting the base metal. The dimensions are intact here, including the threaded portions, and the surface looks better than a new product. So it has a glossiness also. So we have removed all the metallic oxides, the corrosion products, and again, this is ready for subsequent phosphate coating. One of the important thing here, what I want you to note is when we clean this, it is quite obvious that when it is exposed to air, the oxidation happens and immediately the rusting will happen. This particular composition avoids the flash rusting also. That is the immediate rusting. Most of the time, you may not see that also. The initiation of corrosive ions by naked eye, you cannot see. You can only see the stable state of this ion, that is nothing but Fe2O3, which is the stable state of ferrous. So when we say this is free from the rust, by naked eye, you can never say it is free from the rust. That is a very, very important point. And one more biggest problem what industries are facing is with respect to HRCA. What is HRCA? Hot rolled, close annealed. We have two types of steel. One is HRCA and one is CRCA. HRCA is hot rolled and CRCA is cold rolled. When we talk about HRCA, from the mill, we have these things. Since it is treated at a very high temperature, we have the oxide, and other term is called as a mill scale in general. This mill scale are quite tough and adherent, and without removal of this mill scale, you cannot process the particular steel for your required operation. And the conventional way is either they do the sandblasting or the shot blasting, or they use high concentrated acids or the combination of acids. In spite of that, the surface finish, they are not quite happy, except for the sandblasting, where it removed the mill scales are removed 100%. But the problem with the shot blasting is when you blast on this particular surface, one thing is it creates a roughness on the surface, and it is so rough, the RA value, whatever we want, you will lose that. The smooth finish will go away. And when you want to paint it further, instead of 1 liter, you need 3 liters of paint. That is 1 into 3 times of the paint to cover all those roughness. So unnecessary will be wasting that particular paint or the VOC, which is causing due to thinner, and the labor also. Like this, there are many associated problems when you double or triple the requirement. What we have done is, in our citric acid based solution, you just dip this, it completely removes all the oxides, particularly the mill scale, and without affecting the base. You can see the surface is very shiny, which is very, very smooth. So this particular surface requires only minimum painting and minimum labor is involved to get the work done. So this is one of the very good or a big project which we have established in few of the industries. And how it works. This is one of the component which is having some kind of a scale. It is nothing but hard scale because of the calcium and magnesium. We know hard water scales, you can see, and the rust also. This is how it works. This we are dipping in our temperature solution, which is nothing but a citric acid based solution, as I said. And immediately it starts reacting with the water scales. As I said, calcium and magnesium mainly. It is just a neutralization reaction, that's all. All of you know this is the basic and this is acidic. So this is because of the neutral reaction, naturally the scales will dissolve. And iron, since it's a citric acid, it acts as a chelate. It removes the iron from the surface, and after some time you will get a clean surface of this particular component. And it is the basic issue or the problem, as I said, is the fumes with respect to the conventional acid. Here there are absolutely no fume, no smell, and even in an AC room one can use this very easily, very comfortably. It's just like water it looks, that's all. And the best part is you can touch it by hand also. That is, it is non-corrosive. Of course, we are not recommending anybody to handle it throughout the day or continuously in the production scale. Accidental contact, you are very, very safe. So this ensures the total safety on the person who is going to use this, and we are not spoiling the environment, and we are cleaning the component all. So some of the photograph like this, where it has a diesel engine cylinder head, this particular thing which we established for Cummins Group very long back. You have the carbon scales, you have the rust on the iron surface, which is totally clean using a similar technique. So it is free from all the contaminants. You can appreciate inside the port also it is clean very well. So there is no manual intervention like scrubbing and other things, the laborious process is not there. It is only dip it in our solution followed by a water spray to displace all the contaminants. So this is with respect to the steel like this, as I said, of course, I can continue for a long as far as steel is concerned. I just want to give you a few examples. With next, I'm moving on to copper and copper alloys. When we talk about copper and copper alloys, hydrochloric acid, nitric acid is a must. If not hydrochloric acid, nitric acid is a must, which people are using. I'm sure you must have experienced in the laboratory also. This is how the reaction with respect to nitric acid when you dip copper, you can see, but nitrous fume. So we are spoiling the environment and left for you lose the dimension of this component also. So alternatively, what we have done, again, it is a 4 years old, which is highly tarnished. So which we are dipping it in our solution at room temperature. And you can see the exact time of working. It dissolves the tarnish. Tarnish is copper alloys when you have the corrosion corroded surface, we call it as a tarnish. If it is on zinc, we call it as phosphorus. These are all different names. That's all. So immediately it cleans and gives a high brightness also. You can appreciate inside the crevices also it is clean and you have uniform brightness. So from this surface, which is highly corroded, you will get a surface like this without affecting the dimension. Here we have removed the material in a nanoscale. One that is removed, the chemical will stop working and your component can be taken it out. Very, very safe. So this is one more example of copper. Before and after you can see highly tarnished copper. When it is dipped and followed by water, it can be cleaned, something like this. All copper alloys or any product which is made up of copper or brass or tin alloy, it can be cleaned very well. This is one of the example. This is a choked automobile air cooler. Many of the air coolers are there, not only in automobile. When you talk about railways, it will be very huge, of almost a 10 by 10 a room size. So these things, when it is choked like this because of the atmospheric contaminants, it is very difficult to clean or sometimes it is impossible. They just throw it out. So what we have done using one of these similar product, we have dipped followed by a water wash. We can cleanly see it is totally clean. And in this photograph, you can see before and after, even the pores are opened very well and it is as good as a new product, which can be reused for many number of years again. So like this, we can not only clean, we can increase the lifespan of a particular product, which is made up of copper, not only copper, most of the metals and alloys. And as I said, these are all so safe, non-toxic and non-hazardous. Even some of the worship places, this is one of the temple doors, outside doors, which is having a brass covering, which is highly tarnished. We have just sprayed our solution followed by water wash. You can appreciate the glossiness which you have. It has removed all the oxide scales or the corrosive ions on the surface, and you have a brilliant finish. And some of the idols like this, which is before, can be cleaned and you can get a beautiful finish. There is no plating on this. There is no gold and other thing. It is a original finish what it has. When you treat it, you will get. So most of the metals and alloys like this, it is not only copper alloys, as I said, stainless steel, aluminum, ferrous, even gold, silver, all these can be cleaned, prepared in a particular way so that it is ready for the next operation. And when we talk about stainless steel, one of the important aspect is, as I said, whether it is copper, aluminum, steel, or including stainless steel, particularly for stainless steel, people use a combination of hydrofluoric and nitric acid to remove the weld scale and to pickle and passivate it, which is very, very hazardous and very toxic. We have replaced all these toxic things and with the citric acid base again, From this sort of a stain, we can clean and make it as good as new. So any kind of weld marks or any process contaminations can be cleaned very well. And this we have developed for metro cars here. And since so many years, they are using it very happy. Earlier, they used to import that. That too imported one was hazardous one, as I said earlier. And talking about aluminum and aluminum alloys, you can see this is one of the high silicon aluminum component. Left side is before treatment. You can see all the contamination, and right side is after treatment. When you have a high silicon alloy, it is very, very difficult to clean aluminum. Conventional ways, again, use hydrofluoric acid followed by nitric acid to clean that, which is very toxic and dangerous also. For the first time, we have established, and globally this product is going. This we developed straight away for Germany itself. And some of the similar metals, this is an aluminum again before cleaning, and this is after cleaning. Here, I would like to tell you one more thing. When you clean the surface, how do you know the surface is cleaned and to what an extent it is cleaned? As I said earlier, cleaning has to be 100%. There cannot be 98 and 99%. And we have various methods for testing. The simplest is a water break test. And we have the other tests like millipore test and other thing. One of the common tests, the easiest test in the production what they use is a surface energy test, or this is also called as surface energy test pens. The pens are in the range of about 38 to 44. So 38 is the minimum cleanliness what it says, and 44 is the maximum cleanliness. When I say minimum to maximum, it doesn't mean that the percentage of cleaning I'm talking about. Some of the applications, say for general purpose engineering application, the minimum most cleanliness what is required is 38 pen it should pass. And probably for aircraft application, it has to pass 44. This is an automobile component where it has to pass at least 38. That was the specification. And we were able to get up to 42. The idea is when you draw a line using this particular pen, you should get a straight line without any breaks, which you can see on the top. This I will just show it to you, which he is testing on this. You can see one strip it will have. So this indicates the surface is totally clean and the pen number is 42. If you can closely observe in one of the things, you can see that. So it has surpassed the test standard which Germans were looking for. And for the first time globally, this is the only eco-friendly finish which is available, or the technology to treat high silicon aluminum alloys. And it is very well established since so many years. And there are lakhs of components who are treated using this. In this particular solution, it has passed all the tests. Not even one rejection. So consistency is also there. So this is one of the testing methods which I wanted to share with you all. So like this, any metal surface, as I'm repeating, the main important thing is you have to prepare in such a way that the subsequent coating should have a proper adhesion so that the life of the product can be enhanced. If there is not cleaned properly, you might have comes out after a few days. You can see the corrosion, whether it is a ship or railways or any other, including household. These things will happen only because if the surface is not prepared properly. So proper preparation of the surface is one of the important aspects. Equally important is use green chemistry. That is the most important thing. So now I will be giving you a few more slides, which gives you some of the examples of how a waste can be recovered. So let me tell you, when we talk about waste, we can name some of the waste like we waste time, we waste food, we waste water, we waste opportunity also. What is that opportunity? All of us are studying something. It is a study time. If we miss, we miss that opportunity. And there is an opportunity for all of you. I'm very sure, especially youngsters over there, it's an opportunity for you to become a scientist, to become a doctor, or whatever the dreams that you have. But if you don't use it properly, you miss that particular opportunity. So whether it's a time, food, opportunity, or even the potential. When you talk about the potential, all of us know that all of us equally blessed with equal intelligence. You please take it from me. But how we use it, how we improve it is up to us. That's why I said the potential what we have, the opportunity what we have, the time what we have, if we use it properly, definitely there can be nothing like waste. Anyway, Just to give you an added picture to this, even this I was also not knowing. So when I was browsing, long back, I was able to see this. One apple consumes about 125 liters of water. So when you seed it, when it grows and turns to apple, and when it comes to your table, it has consumed almost about 125 liters of water, basically. Like this, you can see if you are eating a 100-gram chocolate bar, it has taken about 1,700 liters of water. It is required to get into to manufacture 100-gram chocolate bar. So when you say that I have taken one chocolate bar, it's as good as you have consumed 1,700 liters of water. And if it is a cup of coffee or a cup of tea, it takes a footprint of about 130 liters. So what is that it shows? I'm not telling that you should stop eating chocolate or you should stop eating or drinking tea or coffee and such things. This is a life which is gifted to us. You have to enjoy. But the idea is it really required? Is it enough? Have one chocolate. If there is a half chocolate which is left, unnecessary, okay, let us consume it. Or unnecessary, I don't have any work, okay, let's go and have a cup of tea. These tendencies, we need to avoid. So whatever you want to consume just which is sufficient for you. That is the most important thing. So balancing of this is very, very important. The same way, whether it is time or what is that, and what aspect you are spending your time, that is equally important. So like films, friends, or time pass, or gossip, and all those things is a part of their life, which is very much required. I agree with that, but keep it minimum. So if you are aware of all these things, I'm very, very sure there cannot be anything called as waste in anybody's life. I will give you some of the example. This is a cup which you have seen. This is a paper cup, one time use and throw for water or drinking tea or coffee. Especially in malls, you can see all these things, or in any of the ceremony. So here, this is called as a hazardous thing only because of the presence of the plastic, which you can see that. So once you remove that plastic, the extreme right side, you have the paper pulp. And the cost of this paper pulp is almost about 320 rupees per kg. So imagine so many tons which we are scrapping it as a hazardous waste, just by we are burning it. Instead, some of us can take an initiative and start recycling, which many of the people are doing it now. It's a very simple technology. All these technologies I can give you free of cost also. If somebody is interested, they can approach me very well. So which you can recover this particular paper pulp. And this paper pulp, for your information, more than 70%, even today, India is importing. And all of the paper is definitely the source is any tree. You have to cut a tree to create this paper. So instead of calling it a hazardous waste and burning it, if you can reuse it, definitely we can save lot many trees. It's good. It's a win-win situation for all of us. The second example is, this is a grinding sledge. What is grinding sledge? When you want to take a particular shape from a metal, a fine removal of the material is required. The operation is called as grinding. I'm sure all of you know about this. When you remove that particular metal, you will have a sludge, something like this. In the left hand side, you can see it is nothing but contains the metal. Basically, the metal what we have removed it can be iron to a stainless steel. Any metal it can be, any alloy it can be. So this is called as a hazardous waste because it contains some amount of oil, because oil is used for grinding as a lubricant, and you will have some kind of the abrasives which erodes the metal. So that is how this particular product is ended as a hazardous waste. And the practice right now worldwide, it is not only in India, is just to landfill it. There is no other process. And there are thousands of tons of this particular grinding sludge is being landfilled day in and out. And some of them, even the cement industries are using as a calorific value. But how long we can waste things like this? Because iron ore is just the only source what we have, and it is depleting day by day. So what we have done, we have separated the oil, we have separated the abrasive, and we have recovered the metal part of it. And right side you can see the metal which is recovered. We have got in an ingot form, which is as good as your raw material, which can be melted and used for any of your requirement. The same thing, it can be get in a fine powder form also, which can be used for some of the sintering or metal injection molding. There are many applications which you can do. Or simply when you react this with sulfuric acid, it can be a ferrous sulfate, which is used for agricultural purpose. So there is always a lot of energy which is available in any waste. Only thing is one should have some patience and work towards converting a waste to a wealth. Even some of the examples like this is a anti-static wear. Before painting, the painter will wear that, so that the overspray of the paint will deposit on this particular anti-static wear, and after some time, this is considered as a hazardous waste and they burn it. And the cost of this varies from 400 rupees to 2000 rupees. Just by a cleaner, you can clean or remove all these things, and you will get a spick and span and as good as new surface. This we developed for Daimler. This was costing about 2000 rupees per piece. So here we are not only saved money, we have saved a lot of energy also in terms. Otherwise, to manufacture this, you can imagine what is kind of energy which is required. Similarly, some of the painted plastics, when you clean it, it becomes as good as this, which has a better value. This is a small video which demonstrates the removal of the paint, not only from plastic, from most of the surfaces like metals and other things, we can use it. So we have dipped and removed it, and it will come out like a peel without affecting the base. The problem with the industry is, primarily the plastic oriented. Like if you take TVS or Honda, which manufacture these plastic bodies, Honda or other two-wheelers and other things, because of the some kind of mechanical mistake, the painted surface will get a scratch or something, and they reject it. They reject including the plastic. So with this technology, they can remove the paint and reuse the plastic. So some of the things like this plastic painted part, which is a handle, partially we have removed the paint. So after removal of the paint, you can reuse it. It is not only the paint, even the metallic coatings. Most of your taps and other things, you can see these are all plastic coated with chromium basically. So when it is rejected, the whole plastic is going as a waste. So instead, we can always remove that particular coating and recoat it and reuse it. Even a very small thing, like gloves. Any industry, they will have to wear a gloves for the safety purpose. And when you take companies, automobile companies with 2000 employees, you can imagine in a day or two, about 2000 pairs of this particular thing is produced as a waste. The immediate third day, they just discard it, and end of the day, they burn it. Always you can use the right cleaner, clean this and make it as good as new, because the cotton is will have almost about 400 years of life unless you cut it. So this can be cleaned any number of times and it can be used. These are all some of the costly gloves you can see before and after. And let me tell you, companies like Bosch, they use about 1.5 lakh to 2.5 lakh pair of gloves in a month. You can imagine so many companies, so crores of gloves are being wasted day in and out. So one can always think of putting a laundry and recover it. There is a lot of money also in that, apart from the environment angle. And this is for a Mysore Palace ground, which you can see the one square which we have cleaned it, the beauty you can see. So sometimes it is aesthetic, sometimes it is functional. Most of the time it is functional thing is required. Here it is only aesthetic before and after. And even our household things, these are the taps where you can see the deposit is nothing but again a hard water deposit. Once you clean it, it will be as good as new. Or even the ceramic sinks like this can be cleaned and made it like this. It will be as good as new. This is a glass surface. The black color what you see is the driver's seat, and the glass is totally stained. You cannot see the bus standing on the other side. So when you clean the glass, you can see now the bus standing on the other side. So whether it's a glass, rubber, polymer, or tile, or wood, or any metallic or non-metallic surfaces, always you have a right technology, which is green technology, to clean it and recover it. See, this is highly stained glass. You can see the right-hand side topmost, we have covered one particular area. The transparency is obtained. So you can recover all the stained glass, something like this. These are all the filters which industries use, filtering air filters or oil filters. So many filters are available, even water filters. This is one of the filter which was imported from Germany. It costs very high. This we were able to clean it and recover it, and which you can reuse it. And this is a choked stainless steel paint booth filter. When you clean it, you will have a spick and span surface. Like this, I can go on telling you, giving you a lot of examples, because we are there for the past more than 30 years. And individually, I'm doing this from almost about 38 years now. So in my opinion, there are a lot of opportunities outside for all of you. But the most important thing is always keep your priority and the environment first. Of course, the safety and the health. When you consider or when you develop a technology or when you work, keeping these points in your mind, obviously you will come up with a technology which is useful for everybody, particularly for society. This particular photograph, I think most of you must have seen. This is nothing but a tortoise when it was baby, there was some plastic which was thrown as a waste, and unfortunately it has got into system in the stomach side, it was there when it was baby, and it has grown after 14 or 15 years. Except for that tummy part, all the other organs have grown. Only because of the presence of the plastic, it was unable to grow that particular area. You can imagine the struggle what our tortoise has, the torture it has undergone. It is unimaginable. So, with or without our knowledge, when we throw some waste like this, and when we don't have the concern for the environment, anything can happen, like indirectly or directly, spoiling the life of something like this, a plant or an animal or a human being also. And most of the time, it can lead to death also. So many fishes have died in the pond. So many stories we hear every day. These are all the things. Who is responsible for this? All of us are responsible. Either we need to learn to adopt the right technologies or develop technologies, or at least create awareness among all the people that which is the right technology, is the right one which should use. So coming to the last slide, what I feel always is waste is nothing but A positive or A negative. It's not a blood group, it is our attitude. If you have a positive attitude, it always well. And if it is a negative attitude, like I cannot do, government is responsible for that. Like this, you all of you know it very well. Let me not get into the depth. So it is in our hands. We are responsible to create wealth or waste. It starts and it ends with us only, including our own life. We are responsible to make it success or make it a failure. This is my company, which Pyro Technology, we try to have this green chemistry for surface treatment metal finishing. And we have established not only in India, in abroad also, like Japan, US, and we have established standards in terms of finishing by replacing many of the hazardous things. So I'm happy to share that there are so many awards, recognitions, all these things can come. But anyway, those are all the byproduct. We are more happy because we have done a bit towards the environment and contributed for in the science of the metal finishing, where we focus on some of the things like alternative clean technology, design development, manufacture, supply eco-friendly products, both for domestic and industrial, failure analysis, waste recovery, R&D, training, consultants. These are all our focus areas. And definitely, I would like to thank the companies who has given us an opportunity to work with them and develop all these things. Without them, it wouldn't have not possible at all. And this is my team. Always, I'm proud and thankful to them for all their cooperation. And I equally thank the Dayanand Sagar College for inviting me to share my work, particularly Dr. Anant Raju and his team. And definitely, I would like to thank all of you over there for your patient hearing. So if there are any questions, definitely I would love to answer. Hello.
Students, if you have any questions, you can, you are feel free to ask the questions. Unmute yourself and ask the questions. Sir, can I have a question, sir?
Yeah, please, madam.
Sir, I wanted to know, after you clean the surfaces, after the treatment, how do you again clean the solutions which are again, because of a lot of impurity, you need to recover them also, no?
Correct, correct, correct. You are right. Basically, what happens, the organic, like oil and grease, it floats on the surface. You can skim it and remove it. And the inorganic particles, usually they will settle down in the bottom, which you can filter it. And if it is very fine, we need to use filter presses to clean the cleaner, and which can be reused. And as far as the paint is concerned, as I have shown in the video, it comes out like a peel which can be filtered. So most of the contaminations will be get separated on its own in the solution if it is allowed to stand for some time. This is one of the advantages when we work with green chemistry. So recovery is definitely quite easy and possible, but it doesn't mean that it can work for years. It can work for about 8 months or 9 months or up to a year. Later on, there will be the main ingredients, it will be consumed and it has to be discarded. And it can be discarded by maintaining the pH to 7. Since these are all non-toxic and totally biodegradable, this can be straight away drained after considering the pH, neutralizing, you can say.
Okay, sir. Thank you, sir. And it definitely has a shelf life. That is what you also want to tell.
Yeah. Usually about 2 years, the shelf life will be there. Afterwards, as I said, these are all biodegradable. It starts degrading and you may not get the right effect. The right desired cleaning effect you may not get. So up to 2 years, there's absolutely no problem.
Okay, sir. And there is a question from the student. The
Yeah.
question is, how is the product priced as it is has a competition with the other chemical products? That's the question, sir.
That is a good question. Here, the price of a particular per liter, if you take, definitely it is more. Say, for example, hydrochloric acid is hardly about 2 rupees per kg. And our product is in the range of 200 rupees per kg. There is no doubt about it. But out of 1 liter hydrochloric acid, how much area of the rust you have removed? When that comes into place, our product is less than 2 rupees. It is always economical when you use a citric acid based solution compared to hydrochloric acid based solution, because citric acid base is 200 rupees per kg as on today. So definitely per kg basis, there's a lot of difference. But when it comes to the consumption part of it, the area part of it, you can clean more area. Not only that, is the direct benefit I'm telling. Indirect photograph, hydrochloric acid will generate a lot of toxic gases. For that, you need to have special arrangements like exhaust, the motor will run, and you need to have PPCs, personal PPCs, and you have to store it in a separate place, like considering as a hazardous storage area. So like this, the money is spent in so many, every 3 months or 6 months, company will repaint the whole structure. It is only because of the fume that gets into the building structures or even the finished product. And to add to this, we have seen in the industry, these fumes will travel kilometers together. Even some of the finished products, it has deposited on that and it has spoiled the whole day's production. So there are many problems associated with like this. And those are all not there when you talk about the green product. So obviously it is very, very cheap. And for your information, the practical example is, since 30 years we are selling all these chemical. Initially, there will be some kind of a reservation when they think about the cost, but when they start working on that, they will not leave this particular thing. And added to this, I would like to add one more thing. If you import these solutions, it will cost you 10 times more. So now, not only in India, throughout the world, the market is open. So you have the option to import also. When they come to know that particular price, obviously they'll be very happy buying our product. Hope I have answered your question.
Yes, sir. There is one more question from the students. So after cleaning, are there any greener ways to avoid corrosions, like by coating or any other such methods?
It's a very good question. Definitely yes. There are many options which is available to protect. Here, since I have focused only on the surface treatment, basic pre-treatment, I have not talked on those particular aspects. As a post-treatment, it comes where the protection is definitely possible. And it is not only for 1 or 2 days, even about 10 years, you can protect the steel without any issue using green additives. Definitely it is possible. And we have developed an alternative for these rust preventive oils, which are water based. Usually when people say water, they have an idea that it corrodes the metal. No, when you add the right additives, water will act as a preventive for all these things. So we have developed many technologies for prevention also, which is being used in many of the industries. Definitely yes, definitely yes.
Okay, sir. Thank you, sir. So is there any other questions, students? You are free.
Yes, ma'am. I have a question.
Yeah, please.
Sir, is there any sector in the industry that startup can emerge, or is the industry saturated?
There are plenty of opportunities for startup. As I said, most of us are what we have seen through your TV or advertisement or visiting industry. Let me tell you, it is not even about 30% of the requirement. Once you get into the industry, it is not only the chemical industry. You take any industry, there is plenty of opportunity, especially for startup. But the only thing is, what a startup has to do is something apart from the traditional or the regular one, or what is already being there. So startup, there are many options. What I suggest is first, instead of what industry needs, look for your interest in which area you want to work on that. So definitely there are many ways. You can, or any of you can be in touch with me also, whether it is for a product or doing some kind of a project, or if you need any information or assistance, definitely I will be more than happy to support all of you in terms of
Sir, because in the
projects or
chemical
products.
industry,
Sorry?
sir, like, sir, because in the chemicals industry, so like
Huh.
any product you try, so there's
Huh.
already competition or knockoffs of Chinese brands. So like there's always an existing other product in competition.
No, I agree with you. The competition will come when you are giving a similar product at a better, more price. Correct. That is what is
Yes,
competition.
sir.
Say, for
Yes, sir.
example, rust remover. Even today, I tell you, if you come up with a green product, there are plenty of requirement. Not only in India, you can export it. Say, for example, for a green product or for the removal of rust, abroad, they are charging approximately about 700 to 800 rupees per liter. Now in India, what we are producing is 150 to 200 rupees per liter. Where is the competition? Now, if you can work on something, even if you are manufacturing at 500 rupees per liter, you have a market. So what you have to do is study the market, know that there is nothing new. All of them or most of them are hazardous in nature. And some of the green solutions are being imported very, very expensive. Always I encourage, whenever I have an opportunity like this, I absolutely don't have any competitors. So I always welcome others to work on this so that we can save the environment in a better way. So it is not only the rust removal, rust prevention, any surface treatment product, if you say it is a green solution, definitely you have a market.
Thank you,
Thank you,
sir.
sir.
It was wonderful interaction, I guess, from the students as well, sir, with some interesting questions there. So, to end this session, I would like to thank Mr. Rajiva Dikshit. It was indeed a pleasure today to be able to listen to you, sir. And regarding various eco-friendly technologies, be it cleaning the surface or treating it, it was indeed a great session. I'm also confident that all the students have hugely benefited by this session. So on behalf of the Department of Chemistry, DSE, I would like to thank you wholeheartedly for this wonderful session, sir. And I also want to thank all the faculties, the HOD of Chemistry Department for their cooperation and contribution. And finally, the dear students for their patient listening and some beautiful questions you had asked, your interaction. Thank you. Thank you also.
Sir, really it is, Raju sir, it is really interesting and there is no doubt.
Yeah.
Before concluding that, to our student, especially to as well as for the staffs, the whatever the talk and whatever the impact you have made to the social concern is really remarkable, sir.
Thank you.
That, because many a times actually from the beginning, last 4-5 years, we were there with you, and most of the time you are doing wonderful job with respect to consultancy, project work, And really it has a lot of social impact with respect to innovative clean technology, sir. I am very grateful to you, sir, for accepting the invitation. On behalf of Dhanasar College of Engineering as well as on behalf of students, I would like to thank you, sir.
It's my pleasure.
Still, I think probably students are very impressed with the talk. They're still, they have the questions. No problem. I'll be sending those questions to you, sir. No problem at all.
Yeah, please, please. It's always my pleasure. Not only today, any students or anybody who would like to have some kind of information, or if you feel I can do something, you
Yes,
are
sir.
most welcome. Particularly student, don't hesitate. You can always reach Dr. Anant Raju or myself or any of your faculty to reach me. Because end of the day, it is not a one-man show which can do something for the environment. It is collectively we need to do it. So any number of people who are working on this, even then I'm sure it will be less. And of course, I have always appreciations for people like Dr. Anant Raju, because every time you have the equal concern, you have the equal attention towards your student. Because once it has become a routine for you, at least as I have seen. So that concern of passing on the right things to the students, it's not only in this field, overall I am telling, is something is highly appreciated. So always the future belongs to student, there is no doubt about it. But primarily the responsibility is people like you who are doing a wonderful job. So I am always there with you for anything, especially with respect to my subject. Thank you, Dr. Raju, and all the team and all the faculty. Thank you. Thank you very much.
Very importantly, physically, we wanted to have you at DSC, sir, very soon. Very soon.
Anytime.
Because of this COVID, we could not able to call in person to college.
Correct.
Shortly, for some of the event, we would like to invite you, sir, for physical.
Yeah, we can. This was a very general thing. We can get into very specific also once I go through your requirement as corrosion science and metal finishing. What are the things that you are covering? Focusing that also we can do. Only corrosion we can talk, or whatever it is. As per the requirement, we can do it. As I said, it's always my pleasure, and I should thank you for giving me this opportunity, because when we share, then only things can happen. That's what I firmly believe. So definitely, I need to thank you. Thank you very much, Raju.
Yes, sir. Thank you, sir. Thank you for your kind words, sir. Thank you.
Thank you.
Yeah. Thank you, madam. Thank you, all the students. Thank you. Thank you very much.